Hey guys, my name is Carla, and today we're going to be talking about something we need to live, our heart. Now, what does the heart do? The heart's job is to pump blood throughout our entire body, and it delivers oxygen and nutrients while simultaneously removing waste. What we're going to talk about today is how the structure of the heart determines its function. So without further ado, let's dive right in. All right, before we can begin, we need to understand the components of a heart. Here's a diagram that I have made. Let's walk through it just a little bit. So we have the superior and inferior vena cava. What that's going to do is take deoxygenated blood from the body to our heart. Over here we have the pulmonary artery. That's going to take deoxygenated blood to the lungs. And then beneath that we have an example of a pulmonary vein. That is going to take oxygenated blood back to the heart. And then last but not least, the biggest artery in our body, we have the aorta right here. That takes oxygenated blood out to the body. Now, the heart is made up of 4 chambers. And those are the right atrium, which is right here. Then we have the right ventricle. Over here we have the left ventricle, and then the left atrium. All right, so now that we understand a little bit more about what makes up the heart, let's tie it all together. How does it pump blood to the body? So I think it's important to note that the right and left sides serve different purposes. The right is going to carry and transport the deoxygenated blood, while the left side is going to transport the oxygenated blood. So let's start with the right side. The deoxygenated blood is going to come in through the superior or inferior vena cava, where it'll go into the right atrium. From the right atrium, it's going to go through the tricuspid valve, where it'll enter the right ventricle. From the right ventricle, it's going to go through the pulmonary valve, where it'll enter the pulmonary arteries, and then ultimately go to the lungs. The lungs aren't pictured here, so imagine that the lungs are right over here on each side. So once it's gone through the lungs, it's now oxygenated. We need to get that back out to the body. So we are going to go through, from the lungs, we're going to go through the pulmonary veins, where we will enter the left atrium, and that will go through the bicuspid valve. From the bicuspid valve, it'll enter the left ventricle, where it will then go through the aortic valve, ultimately going into the aorta. And from the aorta, it is going to be pumped out to the body. So now that we've talked about the left versus the right, meaning the left handles the oxygenated blood and the right handles the deoxygenated blood, I'd like to make mention to the fact that since the left side is carrying that oxygenated blood through the aorta and to the entire body, it's actually the strongest chamber, which in turn means it has a thicker muscular wall than the right side does. So what keeps the deoxygenated blood and the oxygenated blood from coming together? That is thanks to the septum right here. That septum is going to prevent that from happening, which is very, very important and very vital. Now, I did make mention earlier of the valves. There are 4 valves in the heart. They are the tricuspid valve, which is located right here, the pulmonary valve, which is located here, the aortic valve, which is located here, and the mitral valve. What's interesting about them is that they each have flaps. Now, 3 of the 4 have 3 flaps, which is going to be the tricuspid, the pulmonary, and the aortic. And then the mitral valve is only going to have 2. Here I show an example of and these would be all of the others but the mitral, because it has 3 flaps on this one. So this is an example of a closed valve, and this would be an example of an open valve. And over here is a good diagram showing what happens. So as it comes through, it's open, right? But it's going to pinch together, and it's basically going to stop that blood from backflowing into the wrong area. Now, I also have, bear with me, use your imagination. I used a toilet paper roll and some yarn. So here I made 2 flaps in the roll. And so this would be an example of a mitral valve. And we're going to pretend like this is blood. So the blood is going through as we want it to. And we do not want it to go back up. So that valve, what it's going to do, is going to close up, and it's going to prevent that blood from re-entering the area that it originated from. All right, guys, so what did we learn? We learned that the heart is basically a double pump. The right side is going to pump blood to the lungs to get oxygen, and from there it's going to go through the left side, which is going to go back out to the body. Every part of the heart has a specific structure that supports a specific function. Some examples that we discussed: the thick wall of the left ventricle, which allows it to pump at a high pressure. The valves that are designed to prevent backflow, essential. The septum that keeps the two types of blood, oxygenated and deoxygenated, from mixing. These are all great examples of how structure determines function in the body, each part built to support what it needs to do. Thank you so much for watching. I hope you enjoyed learning. Understanding both structure and function is what makes anatomy and physiology so fascinating. Thanks again.